Good morning, everyone. My name is Vishnu Rupesh. I am a BTech student from Jain University, specialized in AI/ML. Today, we are going to see about a topic, computer vision and image formation, which is an interesting topic. Who going to the field of computer vision? This is the one of the most hyped topic we need to learn if you are going in the field of computer vision. Okay, what is computer vision? Computer vision means giving an ability to a computer to visualize the things like what the humans are seeing. Example, we can clearly see and identify an object. If you're seeing an apple, you can clearly see with your eyes and your brain can able to process. It's in a minute second. But in case of computer, it's completely different. They can't able to identify the object, the things like the human way. First, they will need to convert that 3D into 2D. Then they need to go for a computational process. They need to convert that 2D image into a numerical metrics. Then a numerical activity need to be done for creating a pattern and identify the structure of the image. Then only computer can able to predict whether it's an apple, banana, or some other object. It will take time and a lot of computational process need to be done behind it. So we are going into a minute topic of computer vision. Okay, the image formation deals with how an 3D image capture and converting into a 2D structure. That what we are talking about in image formation. Okay, what is image formation? Image formation is the process by which real 3D scenes is converted into 2D using image system, where we use such as camera or human eye. It explains how the light travel from an object, light which from an illuminating object that deflected after it reaching to a certain object, 3D object, and it moved towards the camera or a human eye, where it will explain. It will explain how the light from the object travel and how lens focus the light and how the sensor read it and how it digitalize the reading captured by the sensor. This is the diagram or the structural view how the light source has been converted after the deflection from an object and converted into digital format. Okay, you can clearly see here, you can see my mouse cursor is moving. This one is the point source of illumination, where basically this is a light source which give the power, photon or power. We can basically take it as sun or any other light source. When the light source coming from the illuminating source and it deflecting, and the light source that coming from the illuminating source, then it move towards the 3D object. 3D object we can take it as an apple. We can take it as an apple, which is basically in a 3D structure. When the light uh, coming from the illuminating source reaches to the 3D object, where it will deflect into different direction. You can clearly see the deflection is going in different direction. The perpendicular direction of the, it's an imaginary perpendicular line. We can take it as surface normal. We will call it a surface normal, and the distance between the surface normal and the deflection of light, we will take it as a theta. The radiance, uh, the radiance which defines the intensity of the light after the deflection. Then the deflected light rays will move towards the sensor. Sensor we can take it as a camera or human eye. Human eye have an optics inside it where it will capture it will capture the light details. Within sensor, there is a lot of uh, pixels, semiconductor pixels, which can able to understand the different wavelength of the light, and they can easily capture what the 3D object look like. And the sensor which capture the light rays which coming from the deflected 3D object, and it will capture it. Then the rest of the light will deflected from the camera itself, so we can call as an optical axis. No, optical axis is an imaginary line where we are drawing perpendicular to the sensor. We can call it as an optical axis. We are moving to the next slide. The electromagnetic spectrum. The electromagnetic spectrum, which is an electromagnetic spectrum, is a way defines the wavelength of light, where the humans can only see in a specific wavelength. We call it as a visible wavelength between 400 newton meters, between 400 to 700 newton meters. The rest of the wavelength humans can't hear, the human can't see or hear. Uh, you can clear the visible rays means the different colors VIBGEO, that's defined as the visible rays. Uh, the red, the violet is 400 newton meter, and 700 is red, and other lights come between it: yellow, green, blue, purple, etc. Most of the electromagnetic wave we are used in our daily lives are X-ray, infrared, SAR, synthetic aperture radar, and ultrasonic sound. The X-ray, which is a powerful electromagnetic wave, which can move through our body, but it our bone only absorb the X-ray electromagnetic wave. The rest of them, our skin muscles will transmit the X-ray electromagnetic radiation through our skin, through our body. So the image generated from the X-ray, we can clearly see the bone will be in an dark shade. Rest of them will be the white color. So the doctor can easily analyze that there is any bone fracture or anything happen to our body in the bones. They can clearly understand through the X-ray. Infrared is other powerful electromagnetic wave, which can capture the thermal. Every body will generate an electromagnetic wave. Especially the heat. The heat of our body can be analyzed using the thermal camera, which can use as a night vision, which only to capture the wave, electromagnetic wave, which generated by the hot object, and cold object will be defined in a blue color. Rest of them will be in much brighter. Even the cup of coffee can able to generate infrared rays, which is used in the military area for detecting any animal or humans are moving. You can clearly identify in the nighttime. The SARS, synthetic aperture radar for terrain mapping, it is basically used by the satellite, which is a powerful wave which can able to penetrate through the cloud and easily get into the Earth's surface and reflected back, so they can able to clearly identify the structure of the Earth, and with the help of the software they can create a 3D map of our Earth. Ultrasonic sound. Ultrasonic sound. It's an beyond beyond our beyond our human limit. We can't hear that. Only the animals like dog, cat can hear the ultrasonic sound. ultrasonic sound is used for some communication purpose, uh, and other sorts of mapping it is used in the for our daily purpose. The some of the most used application of the image formation in the real world are the pinhole camera, which is an easy explanation how the light split into the it's how the light white light is made up of different colors. We can it's a simple experiment to understand that the light has a different the white light has a different color. In our school where I tried this one, this is the pinhole camera, where the light rays which coming from the outside will be pass through the tiny aperture pinhole and form an inverted image. Inverted means is after it moving from the tiny aperture pinhole, it form an inverted image on the sensor plane. By using a similar, why we can able to see in film that the image generator will be in upside down. This is the formula written here. X by F equal to X by Z. By using a similar triangle, we can also map the 3D point X and Y to a 2D point. What is the role of the lens over here? The pinhole let the very light and lens gather more light by introducing a challenge of focus. Aperture control the amount of light and the circle of confusion. Depth of field, the range of the distance where the object appears sharp. Trade-off, the large aperture equal to more light but shallow. The small aperture equal to less but deeper light. Application of image formation, where the image formation is used in the medical imaging purpose, X-ray, MRI scan, CT scan, and ultrasonic to form the internal body image. The surveillance system CCTV capture the face, object, and activities in the nighttime. I already said that at nighttime it has a purpose. Computer vision used in the object detection, face recognition, and tracking. Autonomous vehicle and robot help in the land detection, obstacle navigation, etc. Satellite imaging used for map, weather forecasting, remote sensing, etc. This is the various source I gathered the information for creating the PPT. Thank you for watching my video. I hope you understand the topic image formation. I explained it well, I think so. Thank you for watching. Have a nice day.